we'll quickly discuss three straightforward topics: symmetric encryption, Diffie Hellman Key Exchange, and asymmetric encryption. So let's start with symmetric encryption. So the idea is very simple. A and B, they want to exchange some information such that only A and B can access that information and no one else. So first, step one, A and B meet and they come up with a shared secret between the two, right? So this must happen over a secure channel. So they must probably meet and kind of come up with this key amongst themselves. Second step, A simply takes the data, whatever they want to send to B, and it encrypts that data using the shared key that they came up with in the first step. The output of this will be what we call as ciphertext, or basically it's a bunch of gibberish that no one can understand. Then this is sent over to B, and B can apply the shared secret that they have, and B can get the original data back. That's it. That's symmetric encryption for you, right? But as you can see, there's a problem in this process, is that they must first come up with the shared secret between the two, and if they had a channel where they could establish a shared key in the first place, they might as well exchange this data using that same channel. Why do this? Okay, so in order to solve this problem, we have something called as an asymmetric encryption. In order to understand asymmetric encryption, first of all, we must understand what is Diffie Hellman Key Exchange. Okay, let's get to it. So in Diffie Hellman Key Exchange, the idea is you have A and B, and both A and B have a public key and a secret key. And both these keys are produced using elliptical curve cryptography. Okay. Now, in order to come up with a shared secret between these two A and B, let's look at some of the properties of the elliptical curve first. The first property is that the public key is essentially the secret key multiplied by the generator point. And the second property is A into G into B is equal to A into G into B, right? So we can use these two properties to come up with a shared secret between the two over an insecure channel, right? So how we can do that? First, both A and B, they will send the public key to each other. Now in the second step, we can define the secret key, the shared secret key. On the A side, its value will be the secret key of A into the public key of B, and on the B side, the secret will be secret key of B into the public key of A. And actually these two values are equal if you see it carefully. So let's say we substitute the value here. So we get secret key of A into secret key of B into G. So I'm expanding this over here. And this can be written as secret key of B into public key of A, which can be written as secret key of A into G. And as you can see, these two values are actually equal. So just by exchanging public key between each other, both A and B can now come up with a shared secret between the two that only they know, right? Only A knows this because only it has access to the secret key, and only B knows this value because only it has access to the secret key of B. So there is no other party in the world that knows the value of this and this, and we can use this. Now we can use this or this as the shared symmetric key, right? So what A and B will now do is, now that they have the secret key between the two, they can now use this as the symmetric encryption scheme, right? So now what will happen? So the steps will be A and B, they exchange the public keys. Step 2, both calculate the shared secret on their side, and in the third step, they can start sending the data to each other via an insecure channel, because they have they have the shared secret which acts as a symmetric key on either side. That's it.